Welcome to Code with Vinay. In this video, I'll be discussing the string question of the ISC 2016 Specimen paper of Computer Science Practical. Let us understand the question first. The question states that the encryption of alphabets are to be done as follows, and that is followed by all the alphabets along with the code assigned to them. So A is 1, B is 2, C is 3, and so on, and obviously Z is 26. Then there is a concept of the potential of a word, which they are defining as the sum of the code of each word. Like for example, if the word is kite, the total potential of the word kite is the potential of K plus the potential of I plus the potential of T plus the potential of E. So K is the 11th alphabet, I is the 9th alphabet, T is the 20th alphabet, E is the 5th alphabet, and the sum total of 11 plus 9 plus 20 plus 5 is 45. So the thing is, we'll have to enter a sentence which is terminated either by a full stop or by a comma or by a question mark or by an exclamation mark. Then we'll have to separate it into words. Then we have to find out the potential of each word. Then we have to display a table like this. The potential of the is 33, the potential of sky is 35 and 55, and so on. And once everything is done, we have to arrange the words in the order of the potential. That is, the word with the lowest potential, like in this example, the sky is the limit. The lowest potential is which with the code 28. So is comes first. The next highest potential is the 33. So the is coming twice. So the and so on. So this is the idea. So let us begin with the walkthrough. So the first step is we have to create a file for the driver function. So I'll create a new file. I'll call it ISC 2016 question2.java. Now this file is going to contain the driver code, meaning the main function, the input part, and here we'll be calling all our methods one by one. So we'll begin with the main method. We'll first have our main method. Then since we have to get the input from the user, we'll have to say import java.util.asterisk. We'll have to create a scanner object for getting the input from the user. So scanner in is equal to new scanner system.in. It's a good practice to close the scanner class object towards the end, so we'll do it right now. And then we'll begin with the prompt. We'll prompt the user to enter the string, or rather the sentence. So we'll say input colon, we'll put a tab for alignment, and then we'll say that okay, string sentence is equal to in dot next line. So this will allow us to enter the entire sentence in a single variable by the name of sentence. Once that is done, we'll be creating a class like we always do, because it's not just about writing a program, it's writing the program in an elegant fashion. So we'll use proper object-oriented techniques. So what we'll do is we'll create a class, let's call it encryption. Then we'll create an object of that class, and via the constructor we'll pass on the sentence entered by the user. Right now it is showing the error because we haven't defined the classes, but that we'll be doing as we proceed with the video. So encryption obj is equal to new encryption sentence. Sentence will be passed to the encryption. Once that is done, the first step will be, we'll say obj dot show potential, which will display the table of the potentials. Just to give you a recap, this function will display this portion, this word equal to this potential, this word equal to this potential, and so on. Once this is displayed, we'll call the arrange function to sort the words as per their potential. So obj dot, let's say we call it arrange, and after it is arranged, we'll call obj dot display method, and display method will finally display the word, or rather the arranged order of the words at the end. So this is the broad outline of our driver function. So let's begin with the actual coding of the methods. And on the second thoughts, I'm not liking the name because this is not the ISC 2000 question 2 paper, it is the sample paper. So I'll just rename it to specimen paper, and we'll say OK to refactoring. So this will change the name of the class also. So the first thing we need is the encryption class. So we'll go to the top and we'll declare the encryption class. We'll say class encryption, and within the class encryption we'll be requiring these 3 functions along with the constructor. So we'll have the constructor first, encryption string sentence. After this we'll have the show potential, after the show potential method we'll have the arrange method, and after the arrange method we'll have the display method. So our basic outline is done. Now it's time to decide our instance variable. So we'll be requiring 2 things mainly. One array to store all the words, and another array to store the potential of all those words. So we'll take the 2 arrays over here. We are making it private because there has to be an abstraction. We don't want these things to be exposed to the entire program. So what we'll do, we'll say private string word, and this is an array. Then we'll again say private int potential, and this is also an array, and this array will store the potential. Now once the constructor is called, that is as soon as we say this after entering the sentence, the constructor will be called and the value entered by the user will be passed on to the constructor. So within the constructor, the first thing we'll be doing is we'll convert everything into uppercase. So sentence is equal to sentence dot to uppercase. Once the string is converted into uppercase, we need to separate it into words. Now there is one traditional method of separating the words where you tick out each character till you get a white space or the end of sentence character. That is one way of doing it. I have a slightly improved version of it using the split method, and I have made a separate video on that. You might want to go through it, but I'll give you a quick recap right now. So what we want to do is we want to populate our array word with the words of the sentence, and for that we want to split the sentence using the split method, and that splitting is to be done on either of the characters mentioned in the question. That is either a dot or a comma or a question mark or an explanation or an exclamation. So what we'll do is we'll go over here, and the way to do it is that within double quotes you have to specify the string, or rather the regular expression which will allow us to split or break. So box bracket means if any of these character is found, computer will split. So the first character is a space, then a dot, then a question mark, then a exclamation mark, and I believe there was a comma also. Let me check. Dot, comma, question mark, exclamation mark, dot, comma, question mark, and exclamation mark. And question says over here, if you notice, each word of the sentence is separated by a single space. So if any of these characters is found, computer will do the splitting for us. But let's say if this is not given in the question, then you can add a plus over here which will indicate that one or more occurrences will split the word. So what will happen is that this sentence will be split accordingly on the basis of either of these delimiters, and the return value will be an array, and that array will be referenced by the value word. So once this line completes, our sentence will be split up into individual words, and those individual words will be stored inside the array word. That is, word of 0 will contain the first word, word of 1 will contain the second word, and so on. I'll just show you how it is being done. So we go over here and I'll directly print the array just to show it. So we'll use the shortcut method. We'll say arrays dot toString, and we'll just say print the array word. So right now if I try to execute this program and I enter the sky is the limit, notice what happens. We have an array where each word is separated. The sky is the limit. The only thing wrong over here is that by mistake I have converted into lowercase instead of uppercase. So I'll make it uppercase, and just for confirmation we'll run it once more and we'll again say the sky is the limit. And now all our words are being separated into an array. You can see that it's an array due to these box brackets, and then this commas says that these are different elements. So automatically we have got the words into the array. That is the first part. Now the next thing which we want to do is we want to convert this. Now this line is not important, so I'll just comment it out. So now what we need to do is we have the words separated, and now we want to get the potential of each word. So for that we'll make a new function, and the name of the function will be, let's say, get potential. So we'll say get potential. We'll pass the array containing all the words, and then this function will return the array. That means we'll simply say potential is equal to get potential word. That is, this function will be called, we'll pass the array of words, this function will calculate the potential of each word, store it in an array, and return the array which will be pointed to by the variable potential. Now obviously the next step is we have to make this word get potential. So let's make another function, public. The return type is an array, so public int box bracket to denote an array. This will be followed by the name of the function, and within that we are passing an array word, so we'll give string word. So now what we have to do is we have to go through each of these words and calculate the potential of the individual words. So now the first thing is we need to give the size for the array. So we'll say int potential is equal to new int, and the size of the array potential is to be the same as the size of the array word. Why? Because we are calculating the potential of each word. So here inside this length we'll say word dot length. So now we have an array potential which is having the same length as that of the array word, one for each word. Now we'll go through all the words one by one. For that we'll iterate. So we'll say I is equal to 0, I is less than word dot length I plus plus. So this will iterate through each word one by one, and now we need to calculate the potential. So we'll say potential of I, that is the potential of ith word, is equal to, and then we'll create another function specifically to calculate the potential of a single word. We'll break it down into individual basic operations. So get potential, and we'll call the method get potential value because that is what it is doing, and then here we'll pass word of I. Okay, just a quick recap. Potential of I will store the potential of the ith word. So this will iterate through all of the words one by one, and when everything is done we'll simply return the array potential, which will finally be stored in the actual instance variable potential. Now what we have to do is we have to calculate the potential of each word. So we'll go over here, we'll say public int get potential string, and we'll pass the single word. This is not an array this time, this is just a single word. Since we have to find the sum or the actual potential, so we'll say potential is equal to 0. We'll have to take out each character, so we'll say char ch, and then towards the end we'll return the value of potential. So I'm returning it right now so that that error disappears. So return potential. Now let's come to the main stuff. We'll have to extract each character of the word one by one. So for that we'll say for int I is equal to 0, I is less than word dot length I plus plus, and then we'll say ch is equal to word dot char at I. So one by one we'll take out the characters from the word, and please understand we have to find the potential of only the characters, or rather the alphabet letters. We don't have to find the potential of, like, let's say if there's a comma or a dash in between. So we'll just check first that, okay, if character dot is letter, that means if the character is a letter, then only we'll find the potential. And the easiest way to find the potential is we'll say potential plus is equal to, and here comes the trick, we'll say ch minus a, capital A, minus, sorry, plus 1. Now I'll explain what I'm doing right now. So ch stores the character of the word. Let's say the word is kite. So first time the ch will be k, then it will be I, then it will be t, then it will be e. Yeah, right. So let's say if ch is equal to k, we are saying that ch minus a plus 1. Now try to convince yourself. If the value of ch is a minus a is 0, 0 plus 1 is 1. The code for a is 1. Similarly, if ch is equal to b minus a is 1, 1 plus 1 is 2, and b is 2. Let me go to the actual question. So this is what it is. So when you subtract the character, computer actually subtracts the code. So I am saying minus a over here, but computer knows that a is 65. So if I am placing an a over here, a minus a, 65 minus 65 is 0, and the code for a is not 0, it is 1. So we are adding plus 1 to compensate that. Now this calculates the potential. The potential is returned over here. Then the final potential array is returned over here. Now I can notice that there is an error on line 23. Okay, this is a string, not an array, so we have to say parenthesis over here. So this completes our get potential value method. Now the next step is we have to arrange the words in the order of this array potential. That is, we have to sort the array potential in ascending order, but please note we need to sort the words also. So what we'll do is we'll sort the array potential using bubble sort, and when we are swapping the potential, that is the integer value, we'll swap the corresponding words also, so that they are also arranged. So now let us make the function arrange. So we'll go down, the function is already there. So we need a variable to, we need basically two variables for swapping, because the potential array is integer, so we need one temp variable, integer temp variable for swapping the integers, and one string temp variable for sorting the words. So let's have the temp variable. So we'll say string temp word, and we'll have int temp potential. So we have our two temporary variables. Now we have to swap using bubble sort. So in bubble sort, the idea is we compare adjacent elements, and these adjacent elements are compared multiple times. Each times when we traverse from first to last, we say it's a pass. So in order to give a descriptive variable names, I'll call it pass, because that is what it is doing. Now if you have only one element, no passes are necessary. If you have two elements, one pass is required. If you have three elements, two passes are required, which means if you have n elements, n minus 1 passes are required. So let's have a loop. Int pass is equal to 0, and then we'll say that pass is less than, the name of the array is potential, and we'll say potential dot length minus 1, and then we'll say pass plus plus. So this outer loop is going to run for one less than the length of the array. Now let's go to the inner loop. So for inner loop, we'll say for int x is equal to 0, x is less than potential dot length minus 1, and then we can perform an optimization over here. Please understand, when you when you use bubble sort, you compare adjacent elements, and what happens is that after each pass one element goes at its place. So after the first pass, the largest element will be at the end. After two passes, the two largest numbers will be at the end. So actually you need not go till the end every time. First time you need to go till the end, but once the first pass is over, we know that one element has reached its place. So next time we need not go till the end. So even if we don't write minus pass over here, the program is going to run, but it is going to take extra time, and we want to make an efficient program. So we'll say minus pass, and then we'll say x plus plus. So these are the two loops which we require. Now we come to the comparison of two adjacent elements. So if potential of x plus 1 is more than potential of x, then we need to do the swapping. And in order to do the swapping, we'll first swap the integer array. So we'll say temp potential is equal to potential of x plus 1. Then we'll say potential of x plus 1 is equal to potential of x. And then we'll say potential of x is equal to temp potential. So this will swap these two elements if required. That is, if the next element is more than the current element, then we want it in the reverse order. Oh, sorry, we have to perform it in the ascending order. So this will be if the next element is less than the current element, then we'll swap. Okay, so this is done. Now we have to do the same thing for the corresponding word. For that we'll say that, okay, temp word is equal to word of x plus 1, word of x plus 1 is equal to word of x, and then we'll say that, okay, word of x is equal to temp word. So this will swap the corresponding word also. Now once this is done, now the next method is, we have already arranged it, and then we have to have the show potential also, because we are going to print this. And right now the show potential method is empty, and show potential is rather simple. We have already sorted the word, we just have to display the word and the corresponding potential in this format. What is the format? The format is, we have to first give a label potential and then word equal to the potential. So let's do it quickly. So what we'll do is, we'll go to, okay, the method is over here. So first we'll say s out, and then we'll say potential colon, we'll give a tab for alignment. Then we have to go through all the words, so we'll have a loop. We'll say int I is equal to 0, I is less than word dot length, and then we'll say I plus plus, and then we'll display one by one all of them. So println /t for the tab, that is, we want to align. Remember, in this question there is a tab before the potential is printed, so that is the tab which I am printing right now, and that will be followed by the word. So we'll say word of I, that will be followed by an equal to sign, and that will finally be followed by the potential of the word, that is potential of I. So this will display the potential portion, that is this. Now once this is done, we have to arrange the words also, which we have already arranged, but now we have to combine them to get a word. Now in order to combine them into a single word, either you can take a loop, but here we'll use an inbuilt function which can help us to do the job. So what we'll do, we'll go to the display method. Here is our display method, and inside the display method we'll first say system.out.println. We'll display the label output :t, and after that what we need to do, we have an array word which has been sorted now, but we want to club all the words together with a space in between, and there is an inbuilt method which can do this job, and that is string dot join. As the name suggests, this is a method defined in the string class which will join all the words. We want to separate all the joined word by a space, and then we'll pass the array. Simply, that's it. No need for a loop. This can be done simply without a loop. And one more thing, like these kind of things which are not strictly mentioned in the syllabus should be used exclusively in the practical, because in the practical you run the program and you're supposed to solve the problem. You don't want the confusion that whether or not the person who's examining might get confused that what is this. So if you have to use something which is on the borderline of the syllabus, I'll suggest don't use it in the theory paper. But yes, in the practical you may use it. That's not an issue at all. Okay, so now our problem is done. At least theoretically it's done. Let's run it and see whether this is giving the correct output or not. So the first input is, let me copy this input from here. The sky is the limit. I'll copy the input. We'll go to the program and we'll run the program. So we'll say run Java. So we'll say Control-Shift-V, that is paste. Press the enter, and I believe we are getting the correct answer. Yes, the sky is the limit. The 33 sky 55 is. So this is working. Is the sky limit. Let's check it out for the other input also, which is look before you leap. So I'll copy it, and if the input is correct, or rather if the program is correct, we should get leap before look you. Okay, so we'll go to the program. We'll again run it for the second case, and we'll paste it, press enter, and look before look you. So that's the correct answer. So this is how, or rather this is my version of doing the ISC 2016 string question. If you have any comments or clarification or doubts, feel free to use the comment section below. Thank you.
Your feedback is valuable to me. I want to make sure that my videos are clear and helpful. If you have any questions or suggestions for improvement, please don't hesitate to leave a comment or send me a message.